Sunny from Sunny Enterprises. We are introducing you to training you on hydraulic equipment and hydraulic maintenance, and now we are introducing you the concept of aeration. Aeration is air bubbles in the fluid. What are the causes of the aeration? Leakage inlet, number A, leakage inlet lines cause aeration. Number B, control valve O-rings leaking. Number C, shaft seal leakages. Number D, leakages cylinder packings caused by cavitation cylinders. Turbulence or sloshing in the reservoir. Vortexing fluid in the reservoir. Release of air suspended within the fluid. Aeration can be many forms. Large bubbles, foam, or air in various degrees of suspension. It usually causes pump noise cavitation. Small bubbles cause extreme and rapid wear with corresponding vane tip wear. Large bubbles cause vanes to collapse and pound. This with corresponding vane tip wear. Large bubbles cause vanes to collapse and pound. This pounding effect develops rippling in the ring, and the ring will have a dull appearance. This is more apparent on straight vane rings, which are hardened cast iron with extreme aeration. Cases, the wear is so rapid that a ring and vanes can be destroyed within an hour. In many cases, a large step will be worn in the ring contour at the pressure quadrant. When the step reaches a depth where the vanes extend and locks, the vane or rings will break. Also, the shaft can break where it enters the rotor if the torque is great enough. Cures. What are the cures of aeration? Leaking inlet lines. Pipe threaded fittings can be porous. Use an approved type of pipe thread sealer on all pipe threads. Number 2. If the pump inlet flange surface is rough, scored or mutilated, air leakages past the O-ring seal can result. With any of the above defects, air can be pulled into the system. Now B. Control valve O-rings leaking. O-rings are used in the seal against port leakages in many control valves. These seals can be checked by applying heavy grease around the part to be checked. If the noise stops, the trouble has been located and repair can be initiated. On systems which have been operating and at excessive high temperature, the O-rings can harden and take a set. If this occurs, air leakages can result. This is true not only in the pump but also in the rest of the components of the system. Another factor enhancing air leakage is the actual fluid composition. Fluids which have a high sulfur content tend to accelerate O-ring hardness. This is one of the principal reasons for keeping systems operating temperatures down. Normal operating temperatures of a system is 90 degrees above ambient. When operating temperatures are in excess of this value, trouble may result. Maximum operating temperature should be checked at the pump outlet port. C. Shaft seals leakages. Most vane pumps are internally drained. The shaft seals cavity is connected to the pump inlet. Excessive high inlet vacuum can cause air leakage at the shaft seal. Now, the maximum vacuum measured at the pump inlet should not exceed 5 inches of mercury. Now, suction vacuum of the pump should not increase more than 5 mercury vacuum. 5 inches of mercury. Shaft misalignments can increase the probability of air leakages. Past the shaft seal, universal joint couplings or spline couplings can cause seal leakage if not properly aligned. Straight direct couplings should be used. The use of wrong type of tools can cause the distortion of mutilation of shaft seals or installation. The outer diameter of the shaft should be slightly polished before installing to remove any burrs or roughness in the area of the shaft seal. The use of wrong type of tools can cause distortion or mutilation of shaft seals at installation. Shaft seals must be made of correct material for a given application. A material that is not compatible with system fluid can deteriorate the result in a leakage problem. Leaking cylinder packing caused by cavitation cylinders. On applications where a rapid raise and lower cycle is experienced, air can enter the system through a cylinder rod seal. Vacuums in excess of 20 inches of mercury have been recorded in systems without anti-cavitation check valves. This is enough to force the dirt particles past the shaft seals into the system with the air. An anti-cavitation check valve will allow flow from the reservoir to enter the rod area of the cylinder during a vacuum condition. Anti-cavitation checks should always be used to prevent a high vacuum condition from developing. This will lower the possibility of fluid contamination through the rod seal of the working cylinder. Number E. Turbulence or sloshing of the reservoir. Return lines, if improperly located, can cause turbulence and aeration. A plexiglass window should be placed in the prototype reservoir to study flow conditions. Return lines emptying should be fluid level cause bubbles to form in the system. Return lines should always be terminated below the fluid level. Vehicle movements can cause sloshing within the reservoir. Reservoir must be deep enough to prevent aeration. Vortexing fluid in the reservoir. If the fluid level in the reservoir is low and the inlet demand is great, a vortex conditions can develop which pulls air into the pump inlet. In a hydraulic system, vortexing is normally the result of low fluid or poor reservoir design. One of the best ways of curing a vortex problem is to place an anti-cavitation plate over the outlet of the reservoir. This is the common piece of sheet metal at least 1 by 8 inch thick set over and above the outlet opening. This plate will allow flow into the outlet from a horizontal direction and extensively extend and enlarges the reservoir opening. This prevents the vortex condition from developing. Release of air suspended within the fluid. This is considerable air suspended in cold hydraulic fluid. As the fluid warms, air is released into the system. A reduction of fluid pressure will also release air out of suspension. A simple relief valve poppet can create an orifice that increasingly in reservoir. The reduced pressure condition releases air out of the suspension into the system. Relief valve should be returned below the fluid level of the reservoir as far from the reservoir outlet as possible. This allows time for the air released by the relief valve to be removed before leaving the reservoir and entering the inlet area of the pump. In some cases, great return line configuration are needed or air bleed valves used to remove air from the system. A special baffle made of 60 mesh screen can be installed into the reservoir. The baffle should be positioned at 30 degrees angle in the reservoir so that inlet oil is above the screen and outlet oil is below the screen. The top of the screen should be below the reservoir. Fluid level far enough to prevent surface foam from coming in contact with the screen. Surface foam can penetrate through the screen into the outlet area. The screen baffle will eliminate all bubbles except the very small ones from the fluid if designed properly. This is Anand Sunny from Sunny Enterprises. I thank you. Please give us your feedback and we will improve the quality of the videos and the level of our teaching, as the source of teaching is Vickers training program, and also in some cases it is our experience which has given us knowledge to give it to our hydraulic lovers. So love hydraulics. Hydraulic is in everywhere around you, from your body to your aeroplane. My number is 92312 4225-402, 92315-4225-402 for free training, free services, free education for anyone, everywhere, forever. Thank you. Bye-bye.